Alright, so these notes I'm going to do in two videos, one for the front and one for the back. And we've already talked about what isosceles triangles are. And we know that isosceles triangles just means that they have two sides the same. So I can see here that my sides are equal, because that's what isosceles means. But whenever you have isosceles triangles, everything gets a special name. So the two sides that are equal, we call those legs. And the third side is called the base. Now realize that base does not mean bottom. So don't just assume that the bottom is the base. It's the side that is not equal to the other two. So these are our legs, this is our base. And our angles get special names as well. These angles down here, B and C, those are called base angles. And your third angle, the one that's made by the two legs, that's called the vertex angle. Okay, so when you hear reference to any of these things in an isosceles triangle, that's what they're talking about. And they will be referenced a lot, so make sure you know the vocabulary. But something interesting that happens in isosceles triangles, so not only are our legs the same, but your base angles are also congruent. They're also equal. So you'll see these markings. If I circle the markings here, the angles across from them are also equal to each other. So if this angle was 20 degrees, then this angle would be 20 degrees. Okay, so base angles are also equal. So the first thing we're going to do here is just review vocabulary. So looking at this triangle, here are my two sides that are congruent. Okay. And so those are called the legs. So XY, that side, XY, is a leg, and YZ is also a leg. So those two are my legs because they're congruent. And that makes my third side, XZ, that's going to be the base. Okay, so remember, base does not mean bottom. So here XY is on the bottom, but that's still a leg because XY and YZ are the legs. Then the vertex angle, that's the one that's made by the two legs, so that's going to be angle Y. And then remember, this shows me where the base angles are. So X and Z are going to be equal. So that's my base angles, angle X and angle Z. So again, just remember that vocabulary as we're going through this. So now if I wanted to find measures in isosceles triangles, okay, if this is 77 and these two are the same, that means this is also 77 degrees. And it works for angles as well. If I know these two angles are congruent, then that means these sides are going to be congruent. So this one would also be 12 centimeters. Okay, so it works both ways, sides and angles. So your base angles are always the same, your sides are always the same in isosceles triangles. So these last two examples here on the front ask you to find all of the missing angles. Okay, so first thing I'll do is, again, I'm going to draw these markings so I know that this angle is 58 degrees. And now to find my third angle, I'm just going to take 180 minus 58 minus 58, because I know all three angles are going to add up to 180, and that gives me 64 degrees for that one. Now this second triangle is just a little bit different. So it's pretty skinny here, and here are my markings. So I know these two angles are going to be the same. However, I don't know what they are because I'm given 10. So we have to solve this one just a bit differently. So first I'll take 180 minus 10 degrees, which gives me 170. And now these two angles are equal. So I'm going to divide it in two. And that gives me 85 degrees for each of these. 85 and 85. Okay, so if they give you a base angle, the other base angle is equal, and we just subtract from 180. If they give you the vertex angle, then you have to subtract from 180 first, and then divide by 2 to get your two base angles. I am actually going to do these two slides on the back as well with this video, and then I'll do the last two slides on another video where we're solving for x. So these are the same questions actually as the previous slide, it's just now they're giving you a description instead of a picture. But you can draw the picture yourself to help you out. So I have an isosceles triangle, and you don't have to draw it perfect. Like you don't have to draw it to scale or anything. Since it's isosceles, I know I have two sides the same. They tell me the vertex angle is 30 degrees, so that goes in here because it's made by the two legs. And now I need the measure of one of these base angles. So again, these two angles are the same. So I'm going to take 180 minus 30, which gives me 150. And then I'll divide by 2 to give me that each angle here would be 75 degrees. Now this one on the bottom, again, I have an isosceles triangle. And I see that it doesn't say that in the problem. It doesn't say the words isosceles triangle, but it still says base angle. So we should know that that means it's an isosceles triangle. So again, these are the same. So if one base angle is 40 degrees, that means the other base angle is 40 degrees. So to find my vertex angle, I'll take 180 minus 40 minus 40, which gives me 100 degrees as my vertex angle. And I can see that that obviously doesn't equal 100 degrees because it's acute and the 100 should be obtuse. But again, your picture is just for your reference to help you out. It doesn't have to be drawn to scale. Okay, one more here we'll do on this video. Find all the missing angles. So I have 1, 2, 3, 4, 5 missing angles to find. Okay, and I can see that these markings are here, so those are going to be the same. So if this one's 28, that means this one's 28. And now, to find this angle, I'll subtract from 180. So I have 180 minus 28 minus 28. And that's going to give me 124. Now, these two, remember, these are called vertical angles. We talked about that before at the beginning of the triangle section. So this one's also 124. And now, to find these last two angles, I'll take 180 minus 124, and that equals 56. And we'll divide that in half, and we get 28 again. So I can see that all four of these angles, 1, 2, 3, 4, those are all 28 degrees. Now, I want you to be aware that only happens when both this triangle and this triangle are isosceles. If this one up here, where the green is, if this was not an isosceles triangle, if this was scalene, then these two would be different. Okay, and on your practice worksheets, there are a few where these are not isosceles triangles. So realize this situation where they're all the same does not always happen. But in this case, it does. Okay, so that's the beginning on isosceles triangles. I'm going to make another video for the solving for x because it's going to take a little bit longer. So those last two slides, I'll make another video for that one. But if you have any problems with this, there's plenty of practice in the crate, or you can certainly ask me any questions to clarify.